Hello everybody, and welcome along to a quick video to remind you about the formation of depressions. Remember, this is on the advanced information, so you need to be well on top of this. We're going to make 2 points about the formation. There's something that needs to be in the position in the surface, that's the polar front, and then there's something that needs to be in position in the upper atmosphere, and that's the jet stream. The polar front bit's very simple, where you've got the TM air meeting the PM air. When they meet, they do not mix. Think P7 discos. Rather, a front forms between them called the polar front. Due to the rotation of the Earth, that can form into bulge. Then over time it'll develop into a fully fledged depression with warm front, cold front, occluded front, and it will have that circulation pattern. If you were to take a look at a weather map, there's typically the kind of thing you would see over here. You've got the fully fledged depression. This is the next depression beginning to form. In fact, if we take a look at a real world map of this, you can see there the polar front. You can see when these air masses meet, they do not mix. The front forms between them. Here it is, the bulge forming the next low pressure system, and here's a more mature depression over there. So those are the conditions you need at the surface at the polar front. But at AS level, we need to talk about some of the conditions you need in the upper atmosphere as well to allow that all to form those rotational depressions, the weather systems. So, remember with the polar front, it's this fast-moving stream of air, the jet stream, I should say, fast-moving stream of air at between 8 to 15 kilometers in height, and it is something that will develop these meanders, these Rossby waves. So, as the meandering of the jet stream takes it back further towards the north, it speeds up. More air is leaving than arriving, and that's going to create a deficit. Atmosphere does not like that, and it's going to draw the air up from the surface, spiraling up from the surface. That's going to help to reinforce the development of the low pressure system and help to get it to that rotational stage there. So there is your moving further to the north, the upper air divergence, which is helping to create the fully formed depressions. Now, just while we're here, we'll take a wee look at how this whole process helps to form anticyclones as well. Because as it spirals down or meanders down towards the south, it slows down, resulting in upper air convergence. More air is arriving than leaving. That, again, is a surplus. I know it says deficit there, but that's a typo. It's a surplus, so the atmosphere does not like that imbalance. It sends the air down towards the surface, reinforcing the high pressure system at the surface itself. So these are three-dimensional features. It really helps to see the atmosphere in 3 dimensions when it comes to this. So I've put this together to try and help you to visualize that a little bit better. This red line here represents the jet stream, say 12 kilometers high, and the blue line represents the polar front starting at the surface. Now, if you look at it from above, you can see how they align, but we can turn this around a little bit and see how the jet stream is sitting above the polar front. And it's that as it's moving back up towards the north that it speeds up. There's upper air divergence. More air is leaving here than arriving, and that's what causes then the air to move up from the surface here, which is going to help to create your low pressure systems at the surface. So we come back into our presentation here. This is a map showing the jet stream, this pink line here. Here it is coming back up towards the north. More air is leaving than arriving. Upper air divergence. This is going to bring the air up from the surface, creating these low pressure systems. And again, just for completeness sake, here's the situation to form the anticyclones. As the air moves back down again, you get convergence. More air is arriving than leaving, and that's going to push the air down towards the surface, creating these high pressure systems. So here is the relationship between the surface air, the surface pressure patterns, and the jet stream. And you can see as I toggle between them, a very, very close relationship. Where the jet stream is coming south, you're getting high pressure. Where the jet stream is going north, you're getting low pressure. And just toggle between those a couple of times so that you can see that in operation. And we'll just check it out then with our satellite image. There is our ribbon of cloud along with the front, which is exactly what we would expect. At our high pressure systems, you can see that there is no cloud here at all because the air is sinking down. Upper air convergence, leads to high pressure anticyclone below. Upper air divergence leads to low pressure depression below. Okay. Good news is that's the form of the text. This is in the presentation, so you can read it yourself. If you read that and that makes sense to you, then you've pretty much understood this. And that's a nice punchy thing for you to learn. If you read that and it doesn't quite make sense, go back to the part in the video where you seem to have dropped off and see how you get on with that.